Welcome to VW 5.2. Today's going to be a pretty quick video, pretty quick lesson, so I'm not expecting this to take very long. Notice how it says graphing a linear function, so you've done this for quite a while now. Graph the linear function, find the domain and range. So really quickly, let's just write y equals mx plus b. I know we've been using point slope plot. Now for graphing, this is probably going to be our go-to form. So just quickly note that for your notes, slope intercept. Recall that m is your slope, b is your y-intercept. At this point in your math career, you shouldn't need to create an XY chart. So for example, I know some of you when you first got to Algebra 2 Honors, making XY charts for lines and like plugging in numbers. This is something you shouldn't have to do at this point, and you're going to have to focus on graphing quickly using this method. So for example, you just start at the y-intercept, which is 7 here. So there's our 7. The slope is -3, so we're going to go down 3. 1, 2, 1, 2, 3, and then right 1. And you can follow that pattern to get more points. Something like that. And there's our line. And of course we can make it cleaner, right? We can understand that there are a bunch of triangles here, like that. And what you can know is that I always go up and down and I always go to the right. But the main thing to understand is this line, if you read this line, you read it left to right, and you can see that this line is going down, which means this is a decreasing line, which corresponds, of course, to our negative slope right here. So I can note that m is -3, which means it is decreasing, and b is equal to 7, and we can see that on our line right there. Oh, let me put that 1 right there. Now for domain and range, for lines, it's pretty straightforward. Because the line goes up and down, left, right forever, the domain and range is simply everything. So anytime you're graphing a linear function, for domain and range, just write all real numbers and then you're good to go. Next example, which of the following functions are linear? If it is, write the equation. So all we're going to do is look for the rate of change. So notice how here I see down 3, down 3. They're all down 3, which means this must be linear. And it's linear if the rate of change is constant. So I'll put equals constant rate of change. So we can write our formula, y equals, the slope is -3, or your rate of change, then x. And the most important point is this one. That's your y-intercept. I'm going to put +2. And there's our equation. Now for these, the rate of change, we can see that this is down 16, that's down 8, down 4, down 2. These values right here, not constant. Which means this is not linear. If I go here, I can see this is +2, +3, +4, +5. So clearly we can identify the pattern, but once again we can see that this rate of change is not constant. Therefore, this is not linear. So again, it seems simple, but I just really want you to understand that this part right here, that's rate of change, and when that is constant, that is going to be a linear function. So now let's do the last example. It says determine whether the following linear functions are increasing, decreasing, or constant. I want you to highlight these, increasing, decreasing, or constant. What's important to note is that these are referring to the slope. Because up here I was saying the word constant a lot, but that was in referring to like what's happening between each change. It's like a constant rate of change. Now we're just saying, if you look at the actual slope, what is actually happening? So for A, we're going to write m equals 5. So I can see that the slope is 5. And then we're going to write, that's a positive number. Therefore, the function f of x, is increasing. So that's how you're going to answer these questions. So for B, we can see m is -2. That's less than 0. Therefore, your function g of x is decreasing. For C, m is 3/4. That is a positive number greater than 0. Therefore, your s function, s of t, is increasing. On the final part, D, this is kind of tricky. M here equals 0. Now, if m equals 0, that's what we call a constant function. So you're going to write h of z is constant. So graphically, it's important to understand that that would indicate it's like a straight line, kind of like this. There's 7, and it would look like that. That's a constant function.